Hello everyone. Today we are going to talk about some other topics in severity coverage modification. So the topics we are really going to talk about is maximum covered loss and coinsurance. Maximum covered loss U is the maximum amount considered in the calculation of a payment. It's different from the policy limit we talked about before. Policy limit is pertain to a whole policy and is considered the payment. The number is with regard to payment, but here the maximum covered loss, the amount is compared to the loss. In the presence of other coverage modification, apply maximum covered loss first, then perform the other modification. So this is the order because we have so many other modifications like deductibles or limits or inflations. But what you need to do is apply the maximum cover loss first, then perform the other modification. For example, maximum cover loss is 10,000, deductible 500, so a company will pay Y, which will be 0 when X is less than 500. When the loss is less than 500, of course we pay 0. When the loss is greater than 10,000, then how much do we pay? First, we compare the 10,000 to 10,000 or X to 10,000 because X is greater than 10,000, so maximum loss is 10,000. But within this 10,000 loss, deduct with 500. That's why the actual payment would be 9,500. Okay, so what if the amount, the loss is between 500 and 10,000? In this case, the loss is less than 10,000, but then we still need to apply the deductible, which is X minus 500, because at this time the payment will be based on the actual loss minus the deductible. Maximum loss in general, Y is equal 0 if X is less than D, D is deductible, and if X is between D and U, then the payment will be X minus D, and if X is greater than U, then payment will be U minus D. This is just a general case from previous example. Now the expected payment Y can be calculated as follows. When based on these three cases above, when it's less than D, then it's 0, so we don't need to consider that. This part is when X is between D and U, then you integrate the payment, which is X minus D, and with the probability density function fx. When X is greater than U, your payment will just be U minus D, but you also need to use the probability density function here to integrate that. So this can be further write as this one. Then eventually you will utilize what we learned before. The integral of X minus D with probability density function fx will be you can use the integration by parts to calculate. By now you should be familiar with how do we do the integration in this part. If you are not familiar, you should look for previous examples of previous exercise, because this has been used several times in this case. However, the final result is what you need to pay attention, where the expectation of Y is equal expectation of X capital U minus expectation of X capital D. This is the final result. This will be used to do the calculation. We talk about expectation of EY. Now we want to calculate expectation for EY square. Before we go on, again, I want to slide out the formula we use. So we know that integral of this will be equal u v minus this. This is the rule we are going to use. Integral of this will be applied to here. So from here we got this part. Assuming this is u, then dv will be dfx. This part will become this x minus d squared dfx, because small fx is just the derivative of bigger fx, so this part will still be there. From here we can utilize this. So u is x minus d is u, fx is v. So here u times v will be here. So u will be x minus d squared times fx minus, now v is this, so v is fx, but du is this. So if we do the derivative of x minus d squared, we got this, and we still have to times the v, which is fx dx, and still we have the last piece. I'm not going, and from here you can see x minus d, and last part is x minus d square su. From here you actually have the fu and su. These two will fu and su is equal 1. So the first part becomes u minus d squared, and the second part is still this. And fx is just 1 minus sx dx. Now for this part, first part, x minus d times 1 is really can be the same as x u minus d. So this part and this part essentially cancel out. All you left is this negative 2 times negative sx, so times x minus d, so you will get this part. My notes is slightly more detailed than my writing, so if you are still not familiar, you should check out the notes. Now let's talk about coinsurance. Coinsurance is a portion of a loss that is reimbursed by insurance. Example, if alpha equals 80%, meaning that the insurance will pay 80% of the loss. So another way is to say that coinsurance is the portion of the loss the insurer is responsible for. Suppose the policy has a coinsurance of alpha where alpha is less than 1 and greater than 0. For a loss of amount x, the insurer will pay alpha x, while the policyholder will pay the rest, 1 minus alpha x. And according to the expected values property, we know that expected value of E alpha x will be alpha times expected value of x. In the case when where a policy has both a deductible and coinsurance, there are two methods for handling coinsurance: before and after the deductible is met. by default, the coinsurance only comes into play after the deductible is met. The payment per loss variable is shown below for policy with deductible D and the coinsurance alpha. So the coinsurance only comes into play after the deductible is met. That's why you have to use the deductible first, then apply alpha in this case, in this payment case. The policyholder pays the first D of the loss and share the excess amount with the insurer. Then the average payment will be expected YL will be alpha times expected X minus expected X capital D. This is generally how we are going to calculate the coinsurance. Earlier we talked about coinsurance where we apply the deductible first, then we apply the coinsurance factor alpha. However, questions sometimes specify that the coinsurance is applied before the deductible. That means instead of applying the entire loss X against the deductible, the insurer will only apply the coinsurance portion of the loss alpha X. The policyholder will still be responsible for the remaining portion, that is 1 minus alpha X, plus the amount needed to meet the deductible. The payment per loss variable is as shown below. For a policy with deductible D and coinsurance alpha, where your Y will be 0 if alpha X is less than D, or alpha X minus D if alpha X is greater than D. Notice the equation can be expressed such that we will get the exact same form as the case where coinsurance is applied after the deductible is met. If we divide deductible D star to be D over alpha instead. So you can see what we're trying to do is just applying the alpha to use the D star to be D over alpha so that we can still utilize what we have deduced earlier so that we don't need to do further calculation. We just need to convert it to further format, then the rest will be the same, such as expected value of y or expected value of y squared. You can still utilize what we just deduced in previous slides once we know that we can convert this format to previous format. Now we have learned policy limit, deductibles, coinsurance, and the maximum cover loss. So in this case, here is the general formula for expected payment per loss when all of the coverage modification we have covered are included. We will modify and apply it to each of the examples later. So we have this formula. If a policy has U, the policy limit, D deductible, alpha coinsurance, M maximum cover loss, that will be equal to U divided by alpha plus D. So this is the formula. Now let's look at some examples. This example, for an insurance policy, you are given the claim severity follow the Pareto distribution with parameter alpha equal to and theta equal 1000. The policy has an ordinary deductible of 200 and a policy limit of 2000. So in this case, D is equal to 200 deductible, U is 2000. which is the policy limit, alpha is 1. So we don't need to worry about alpha in this problem. And according to the formula, E y will be Ex minus Ex 200. Why is this 2200 here? So earlier we talked about this M. According to previous formula, M is U plus D. So M maximum loss will be 2200. This is where 2200 comes from. And once we decided this, then the rest is easy. The rest is just apply the formula, because in this part you will have a formula Ex 2200. This is the formula based on the Pareto distribution. This alpha minus 1 is 2 minus 1, 1 minus 1000, 2200 plus 1000 minus 1. You will get this equals 687.5. Similarly, Ex 200 would be 160.67. Therefore, you can get EY is 520.83. The rest, this part is mainly you recognize M is equal U plus D. This is the most important step for this question. Now let's look at this example. Loss follow exponential distribution with a mean 1000 for insurance policy claims subject to ordinary deductible of 200. The policy will reimburse 80% of the claims in excess of 200. The insurance payment is capped at 2,000. So deductible is 200, alpha is 80%, and policy limit U is 2,000. Yeah, most important, we still need to calculate M. M is alpha. U over alpha. U over alpha plus D, which is 2,000 divided by 80% plus 200, which is 2,700. So once you get this, the rest is easier. It's just applying the formula. E y L is equal 0.8 E X cap at 20 M is 2,700 minus E X cap at 200. So, and this expected value of exponential distribution, you can calculate that easily. The 1001 minus E 2,700 divided by 1000. So this part will be 93279, and this part you can calculate it is the same way, equal this, so it will be this. So eventually you will get 601.22. So earlier we talked about the modifications including deductible, policy limit, coinsurance. Now we just add one more element here, the inflation. So if there's also an inflation layer, uh, before the inflation you have this formula we already deduced. Now with inflation we put the 1 plus r times x to be what x was supposed to be, and we can further deduce it to be this formula. So it's just slightly different than previous, basically just adding another layer there. With this, then we can calculate the expected value, utilize what we have deduced before. Expect payment, also here is talking about expected payment per payment, so you will have a conditional situation where 1 plus r times x should be greater than d. But the rest is just the same. Now let's look at this example. Losses for a insurance coverage have the following density function. Insurance reimburse losses subject to an ordinary deductible 2 and a maximum coverage loss of 7. Inflation increase all loss sizes uniformly by 10%. Calculate the expected amount paid per payment after inflation. So this is asking about expected payment per payment. So there is a conditional format there before we even get to the actual situation. And when it's given Sx, we can easily calculate Sx. Sx will be integral of Sx fx from x to 10 because 0, this is a condition. Then from here we can get this will eventually be this. I'm not going to do the details here, but because this is basically integral, deductible D is equal to maximum cover loss is equal to 7. So M is equal to 7. So expected value, payment per payment, based on the formula in previous slide, it would be 1.1x minus 2. Because this is a formula, the fx is a formula, it's not any normal distribution, so we just have to do it based on the definition of this. We cannot utilize any formulas because this is not a normal or common distribution that we have. So we start with this and we calculate each of these. So we put 1.1 outside, we can get this will be equal x minus 2 divided by 1.1. So divide condition is this. Now we just need to calculate expected value for this and calculate this. We already got the Sx, so we can calculate expected value of Ex 1.1 plus would be this 1.1 divided by 1.1 Sx. This is the formula we can utilize. And Px is just you can utilize the Sx to calculate Px. So eventually this will become This 1.1 1.6656 divided by 6696, you will get 2.7. This is in the notes, so you can look at the middle steps from the notes if you are not familiar with this part. Okay. The second question is calculate the variance of the average payment, taking into account payments of zero on losses below the deductible. Because it says taking into account payment of zero on losses below the deductible, so this tells us this is payment per loss rather than payment per payment. In this case, we can start with writing the payment per loss, which will be 0 if x is less than or equal to 2, and it will be x minus 2 if x is between 2 and 7, and it will be 7.2, so it's equal 5 if x is greater than 7. Now EY you can calculate it using the integral x minus 2 between 2 and 7, you have an integral dx plus 7 to 10, you have this. This will get you 1.617. Similarly, EY squared, you will calculate that to be 2x minus 2 sx. So this is the formula from previous lessons. And eventually you will get to this. Now, with both EY and EY squared is calculated, then this is just the formula for variance that we have been using quite a lot by now. Hopefully you should remember this, and this should be equal to 0.18. Let's look at another example. The cumulative loss distribution for a risk is Fx is this. An insurance policy pays the loss subject to a deductible 1,000 and a maximum covered loss of 10,000. Calculate percentage of expected aggregate loss that are paid. Okay. Now here, first thing we want to do is recognize this Fx. We recognize this is a Pareto distribution. And in this case, alpha is equal to and theta is equal 10 to the third power. So with that, we will know that Ex, if there's no deductible or limit, Ex will be theta alpha minus 1. So it will be this 2 minus 1 will be. But with deductible, and we know that Ey will be Ex capital U minus Ex capital D, where U is 10,000 and D is 1,000. Okay. Now, since we already recognize it as a Pareto distribution, then all this can be calculated based on the formula from the formula sheet. So I'm not going to be too detailed on this one. Ex loss will be 500. Therefore, you can calculate Ey to be 409.909. So the percentage of expected aggregate loss that are paid, it means this is the expected value of a loss. This is expected payment. So percentage they're asking is EY divided by EX, which is kind of 40.9%. This question is actually not very strictly related to what we learned earlier, but it's nice to practice too.